Hey, good afternoon, everyone, and thank you for being here. Welcome to our June installment of ENERCALC Office Hours. Before we start the program today, we're just going to start out with a quick sound check. So if everybody could direct your attention to the lower right-hand corner of your sessions window in your browser, you'll see a chat window. If everybody could just give me a thumbs up in the chat if you can hear my voice right now, and we'll use that to judge, make sure everybody can hear our audio okay. And if anyone is experiencing problems with your audio, refer to the upper right-hand corner of your sessions window. You should see a settings where you can set your audio settings. If you experience audio interruptions at any time during the session today, you can simply refresh your browser or rejoin the session if you have any problems with that. All right, perfect. Thank you guys for confirming your sound check. I also want to go ahead and, before we get to some housekeeping items, we're going to do a sound check for our primary speaker today. So once again, we're just going to have Mac, who's our primary presenter, say hi to everybody. And if you can hear Mac's voice, go ahead and throw a thumbs up emoji in the chat.
Hello, everyone. Welcome to our virtual office hours session for the month of June.
All right, perfect. Now that we have our tech checks out of the way, we're going to go ahead and disable the chat, and we'll move on to some introductions and get going on today's program. For communication with the speaker team from here on, we'll be using the Q&A chat, which is right next to, the Q&A dialog, which is right next to the chat button in your lower right-hand corner tray there. That's how we'll be filtering the questions for the Q&A session later on today. So my name is Seth Roseworm. I'm a senior structural engineer and software developer here with ENERCALC, and our presenter for the monthly ENERCALC office hours is Mac Elterhony. I'm going to go ahead and introduce Mac, and then we'll do just a few housekeeping items and get going. So Mac is a senior structural engineer here at ENERCALC. He splits his time between providing technical training for ENERCALC customers, working with the ENERCALC engineering team on the specifications and technical behavior for our software, as well as maintaining a national presence for ENERCALC at regional and national events. Mac is also the founder and managing principal of ELTA Design Group, which is a specialty structural engineering firm based in Oklahoma City. And he's been using ENERCALC for almost 10 years. And so he's got a lot of great insight about the needs of our customers as a business owner, as a user, and as a licensed structural engineer. So for anybody who's new here this month, our office hours program is basically just meant to open lines of communication between us and our users in several different areas. Mac's monthly programs do showcasing new features and updates from ENERCALC software. We're going to be showing optimized design workflows, answering questions that are submitted in writing in advance of the sessions, and then open forum Q&A at the conclusion of each session. And if there's ever a question that's too involved or requires deeper digging, that might be a better fit for the support team. And Mac will be giving you guys information as well about how to get in touch with the support team. As a minor point of order, you'll notice everybody's microphones are muted just to make sure we don't get any echo or feedback during the session. And as I mentioned, we do have an open Q&A at the conclusion of today's session. So just use your Q&A dialog in the lower right-hand corner of your sessions window to submit those questions. And with that, I'm going to go ahead and hand it over to Mac to get today's session going.
All right. Thank you, Seth, for a warm introduction. And without further ado, we're going to start our program today. So I would like to just give you a brief overview of our agenda today. So the overall agenda for today consists of ENERCALC latest build, register for office hours to get notified, and then we have a did you know segment, and then we have prepared Q&A. Those are previously submitted questions by users. And then we're going to talk about wood beam design, lightning fast, consistently accurate, and then lastly we will have live Q&A open forum. Questions will be open for everybody. So we have a couple of housekeeping items. The first thing is, are you on the latest build of ENERCALC? So if you just open ENERCALC and look at the top, you will find your current build right up here. And we want to make sure that you always get notified of any new updates, so you're always taking advantage of the new features that we have, and we have monthly updates. So what you need to do once you log in, once you're inside ENERCALC, you click on the updates button, And we want to make sure that you always check this. So this way, every time your program starts up, if there is a new update, you'll be notified of it, so you can install it and take advantage of the latest and greatest version of our software. Now, there is an important item here that I want to discuss, which is for users who are on the build 2023 830, which is August 30th, all the way to February 28th. The feature to actually notify of the availability of new updates does not function properly. So if you are one of those affected users, you will have to do a one manual update. If you have this version, which is the March 4th or newer, you're good to go. You don't have to do anything. But if you're just stuck in between these versions, then all you need to do is to do a one manual update. You can do this simply from ENERCALC or through the website URL here, which is enercalc.com/users. To do this from ENERCALC, you can do it just in 3 simple steps. You can click on the update icon, and then you can click here on the on this button right here. This will take you to our website. You can then click on this updater, and it'll download the update file, and then you can just run it. And once you run it, it'll restart the program for you. It'll be on the new build. Everything will be okay. And then lastly, I would encourage you to go back again and make sure that you have this option checked and selected in order to be able to get notified. And it's worth noting that we are currently, this is the most current build of ENERCALC, which is 2024-6.4. This was released yesterday. So we strive to have frequent updates. So make sure that you take advantage of the latest and greatest. The next thing that I have here on the agenda is that I encourage everyone to register for the office hours program so you can get email notifications directly to your email. Typically, the email we have on file is for the IT department or maybe an admin that manages the office licenses. And a lot of times, these notifications about educational sessions don't make it to the engineer. They just get stuck with the IT person, or or maybe they go to just one engineer in the office. That's why I encourage everyone to who's interested in these monthly educational sessions to register on our website to be notified. Of course, you can always unsubscribe as needed, and this is open to active users and non-users alike. With that being said, you can register by either going to enercalc.com/office hours, and if you don't remember the URL, you can just access it directly from our website. All you need to do, just go to for our user tab right here, and then you click on the office hours tab from the drop-down menu. This will take you to the registration page, which is very straightforward. You input your email and your name, and if you're an active user, we ask you to give us your registration number or your KW license number. If you're not an active user, you can just leave this blank, and then you can click on Remind Me about the office hour session. So this way you can get included in the email list for future updates. Lastly, at the very bottom, we update this information regularly. So for example, today it's saying the next office hour session, which is Wednesday, June 5th, and it has all of the times. And if you click on it, this is actually a calendar event, so you can download it and it can get imported directly into your Outlook or your Google Calendar, whatever calendar system you use. And we always have the link right here to join whenever the event is live. So for example, this will get updated, the next couple of days or so, will get updated to the next session. So this way you're always staying in the loop. With that being said, I want to move on to the next segment or the next item on our agenda today, and that is the Did You Know segment. And I found out that a lot of people don't know about our cloud-based storage and access. So as a user, you have multiple ways of accessing ENERCALC, and that's already included with your subscription. The first way, obviously, is the most common way, which is just through the installed application on your computer. That's traditionally the way to access ENERCALC. But also included with your subscription, you can work in the browser. And that means you can just go to your browser, Google Chrome or whatever you like to use, no installation needed. You can just go and log in and actually access ENERCALC. And I'll dive into this and how to do that in just a second. The next item we have that's also included with your license you can store all of your projects and access them from anywhere with the included cloud storage. So all of your company's projects can be stored in the cloud and accessed from anywhere you have internet connection. The last couple of things that I want to talk about is, simple license management. These licenses that we have, or the activations, they can float easily between the desktop installed users, and also they float easily between those who are working on the web and those who are working on an installed desktop application. So if you're at home, if you're abroad, if you're anywhere, you can easily access the software and access your projects with ease. So moving on here. So when you open ENERCALC, in the landing page of the program, you will notice that, by default, you are on the local computer tab. So this right here, that's normally the tab that you're on, and you see all of your projects that are hosted on your local computer, or maybe on your local server. So next to it, you will find the hosted cloud storage. So this is what we're going to talk about today. If you actually click on that, you will see the projects that are hosted on the cloud, by your company that's, using that that KW number or the registration number. So all of the projects associated with your company that are currently hosted in the cloud, they will be right here. All of the engineers or all of the users in your company will have access to all of these projects. If you want to create a new project, all you need to do is you click on create a new project. You'll get this little pop-up window. You put a project name. In this case, we'll just do the Vesta multifamily, and you click OK, and then it will just create right here. And again, I want you to take note that this is hosted on the cloud storage. So now that you can see this right here, I want you now to, we want to, take a step back and kind of see how we can access all of this online. So we created a project and we hosted the project in the cloud. Now we want to learn how to access ENERCALC from a browser. So first of all, go to your favorite browser, and then you can go to cloud.enercalc.com. Alternatively, if you don't remember URLs, alternatively, you can just go again to our website, enercalc.com, and then for our users, and then this is your option right here, log in to ENERCALC Cloud. Now, once you click on this, this will take you to the login page. This is not an individual login. This is not an individual credential. This is a company-wide login, because all users will have access to all the projects that a company hosts in the cloud storage. So this is your registration number, or KW number, and this is a password that you have for just one company. And then you can click launch. Okay, I'm seeing here that someone said that they cannot see my screen. Are we having problems with the screen? Can somebody confirm, please?
I'm not seeing any issues with the screen share on my end, Mac.
Okay. So yeah, maybe if you're not seeing the screen, or if you're having issues, maybe you just need to refresh and try to join in again, and hopefully that will fix the problem. So anyways, to get back to this, you just enter your KW number and then the password, and the rest of these things are optional. You don't have to worry about them. And then you can click launch. And what happens is that, as you can clearly see, we are still in the browser, but now we're looking at an ENERCALC landing page, but it is from your browser. In my case, I use Google Chrome. You can really use anything that you'd like. You can see the project that I already created, which is the Vesta multifamily. So you can see whatever, anyone who logs in with those credentials from any computer will be able to see the projects for your company. And when you open a project that's hosted in the cloud and open a calculation, you will notice that this is an exact replica of the standard ENERCALC desktop installed version. Again, we're still on Google, we're still on a browser. So the same user interface, the same user experience. So there is no learning curve at all. You don't have to install or update the software, and you are ready to go with zero interruptions. So that concludes a little bit about the cloud storage and the cloud access for ENERCALC. And now I want to jump to a question that we get all the time, and I wanted to dive in a little bit deeper into it to make sure that everybody is on the same page. So the question is, I changed the code to IBC 2018, but on the top right corner still says IBC 2015. How can I change that? And this is what they're really talking about. So the top right corner, I magnified this, it says IBC 2015, and then down here it says IBC 2018. So I want to draw a distinction between load combinations and design code and standards. So ENERCALC allows the user to use load combinations that are different from the code standard year edition that you want to use for your design. So this means I can use IBC 2018 load combinations, for example, or IBC 2006 load combination for that matter, with IBC design standard for strength checks or capacity checks. And I want to elaborate a little bit about how you can set up these parameters, understand what kind of fine control you have, so this way you can optimize your workflow a little bit more. So the first thing that I want to draw attention to is this button right here, and I'm magnifying here. So this is the building code and load combinations. So if you click on the building code and load combinations button, you will get the window on the right-hand side. This controls this project globally. So this right here only controls this one specific project that you're working on. This portion of the window, or this window, is split into two parts. The first part talking about the governing code, the second part talking about the governing load combinations. So let's start with the governing code first. So with the governing code part, you can see right here, this is defaulting to IBC 2015. You can select the code version that's appropriate for your project, and this will be the default setting for all calculations within this one project. This will not be the default value for other new projects. So this is only to set the default value for the project, for this specific project. Now, if I want, let's say I know all of my projects from here on out are going to be 2021 IBC. So I want, every project in the future to start as IBC 2021. If you want to change that for all future projects, what you need to do, you need to go to settings, and then you click on the default governing code. And from there, you will get this window. It's a different window. So for this menu, you can pick the code that you want to use as default for all future projects. And if we use the IBC 2021, and click select, then every time I create a new project from here on out, it will automatically default to IBC 2021 as the governing code for all of the calculations that we perform. So to summarize, and I think this is an important distinction, to summarize, if you want to change the code just for one specific project, then you click on the building code load combinations. If you want to change the code for all future projects from here on out forever, and for it to be the starting default value, then you'll have to do that from the setting menu, default governing code, and then you change it from there. We also have an additional feature, and this is project specific feature. An additional feature we have is the customer note feature for state specific compliance, which is this portion right here. So certain states might have additional requirements or amendments to the IBC. In this box right here, an engineer could add a note that says, hey, the calculations have been checked by the EOR and they conform to, for example, in this here, we're talking about the California Building Code 2022 and its relevant amendments. So that's an example right here. So once you have that note, and this note could be anything you need it to be, it doesn't have to be the specific language. This, whatever you put here, will professionally and nicely print in your calculations. This way it looks professional, and it's it's presented in a fashion that is acceptable to the reviewer, the plan checker, or whoever reviewing, or whoever have jurisdiction over your calculations. So now that we learned how to set up the governing code for a specific project and governing code for all future projects, now we want to talk about the lower part of the window from earlier, which is the load combination portion. So it is the same idea. You can set up load combinations for all the calculations within this project only. Also, you can set up load combination to be a default value for all future projects. So if you click on the load combination and then click on save and close, so if you click on just whichever one of these you want, and you just click save and close, that will change the default value for this project alone. Now, if you highlight it and then also click this button, which is this button, I'm just magnified. If you click this button, this says set highlighted load combination as global default for new projects. That means for all future projects. If you do this, what happens is that you will get this little double arrow, and that signifies that all future projects will use the IBC 2018 as the standard, or as the load combination from IBC 2018 for all future projects. So it's the same idea. You can control the load combinations for a specific project, and you can also control it as a default for all future projects from here on out. So now that we changed the code to IBC, now we changed the code to IBC 2018. Earlier it was 2015, and we set the default load combinations value to 2018. You can see here, once we reopen the same calculation, now this changed from IBC 2015 to 2018 the way we want it. We want it to be. Hopefully, this kind of gives you guys a fantastic idea of how to control these load combinations and how to control the code without having to redo this process for every project and so forth. The next portion of our presentation is talking about wood beam design. So we're going to go through a little bit of a workflow of wood beam design in ENERCALC, and that would be done in 3 simple steps. And then we will have a simple verification example following the NDS 2018 to make sure that we're all in agreement. So the first step is obviously just start a new calculation. So the first step, start a new calculation by adding, by clicking on the Add button, and then the Beams tab, and then you click on Wood Beams. This is, it's the same step for every calculation you're about to start in ENERCALC. So nothing new here. The second thing, which is the second step, is just to start working your way through the tabs from left to right. So start from just the General tab all the way to the Load Combination tab. So in here, we're starting with the General tab. Simply, we'll give a name to our calculation, and we'll pick the standard design methodology that we want to use. In this case, we'll use ASD design methodology. The next thing, we want to select the material, the wood species, and the grade from the database. So the database is already provided. It's from the NDS supplemental reference design values. These follow the NDS tables. And here in Oklahoma, it's pretty common for us to use Douglas Fir South and grade number 2. That's what we use for commercial buildings. So you just pick whatever wood species and grade that you use, and you just click on select. Once you click on select, this will bring you back to our original menu, and this will also auto-populate all of the NDS standard design values for that wood material and grade that you selected. So all of your bending stresses, FB, FC, all FY, everything you need, module elasticity and everything. So the next item that I want to draw attention to is shear value calculation, or the shear stress calculation. So you have the option to calculate the applied shear at D distance from support as allowed by the NDS. And if you uncheck that option, then it will use just the maximum shear for your applied or actual shear stress calculations. The last thing here on the General tab is the compression side of the beam. That's the bracing of the compression side. This is, of course, critical when it comes to calculating your beam stability factor, your CL, for lateral torsional buckling. So this is something that you don't have to calculate. You just provide that information, and ENERCALC will calculate CL for you without you having to go through the long process of calculating it. Once that's said, once you're done with this, we can move on to the next tab, which is the beam span data. It's very intuitive because all you have to do is just you put your beam span. We're using 12 feet, and then again, noting that we chose the wood material that we're using in the General tab, now we come and choose the actual size, the beam section that we want to use. In this case, I want to use a 2x11, and this will automatically populate some geometry information for you, like the member width and depth, and of course, area and moment of inertia. Just some geometry factors for you. Note that if you actually change these numbers, like let's say if I change from 1.5 to 2, this will actually recalculate the area and moment of inertia will redo your calculation for you. So I wouldn't touch these numbers if I'm planning on using a standard dimensional number. Moving on to the lower left portion of the beam span data tab, you have the ability here to enter all of the various modifiers. For the NDS, of course, if it's ASD or LRFD, then you'll put the appropriate modifiers. And again, CL is not something that you put here because CL is going to be automatically calculated for you. Now, it's worth noting this is a repetitive member. This is just a joist, so 2x12. So I clicked here saying that use the CR for repetitive member. So this will help increase the bending stress capacity for us. Lastly, on this page, we have, of course, the deflection criteria. You can use, whatever you want for transient load and total load, L over whatever you need. We're using here L over 360. So the third tab in this case is we're very familiar with this tab, which is the span loads tab. The user can apply whatever loads they would like. In this case, we have just a uniformly distributed load of dead load and live load of 20 PSF. We have those right here. You can apply all kinds of loads from, point loads, trapezoidal loads, applied moments, partial distributed load. You can do whatever you need to do here. And then it's worth noting that you can apply the loads as linear loads or area loads. In this case, I'm applying them as area loads. So here it's, pounds per square foot or kips per square foot. And then you have here the tributary width. For us, it's just 24 inches on center. Now, if we have a multi-span beam, this span loads tab right here, this puts load per span. So if we have multiple spans, it'll say 1, 2, 3, and you will apply the loads per span. Now, if you have, for example, a dead load that's applied to all spans, then you don't need to go per beam and apply it individually. All you need to do, you can click on this tab right here, which is loads all spans, and say, hey, I have a dead load on all spans. Maybe you have like a 3-span member, 2-span member, or whatever. You can just apply your load in one place, and it will understand to apply it to all spans. Otherwise, this tab right here is applying loads to specific spans. Lastly, we move on to the last portion of step number 2, which is the load combination tab. You can select the load combination. For example, I'm selecting here, IBC 2018. That's the default value that I'm using. You can add or remove load combinations as you would like. You can also run or not run any of these load combinations, because it says here run yes. You can just click on it and it'll say no, then it won't run it. Also, you can control your load combinations based on what you're trying to do. So the ASD, those are the strength checks load combinations. You can also have different load combinations for reactions, as well as different set of load combinations and values for your deflection calculations. You can, of course, add, delete, modify. You have a great flexibility in terms of load combinations here, and this would allow the user, the engineer, to customize this to their needs. So once you go through this, pretty much you're done with the design, and you're in step number 3, which is reviewing the results. So this is time for the engineer to review the results and make adjustments as needed. If you click on the calculations tab right here, then the summary of results that the user can find quickly, or a quick critical summary of the member performance. So for example, you have, first of all, a green banner versus a red banner. Green saying design is okay. Red banner will say, of course, design not okay. Then you have the maximum ratios, so the maximum bending and maximum shear stress ratios. Now, it is worth noting here that these are actually max stress ratios. That means that your maximum bending ratio could occur at a place where it's not the maximum moment. It might be the maximum moment or it might not. So for example, in case of a simply supported beam, yeah, the maximum moment will produce the maximum bending ratio. However, if you have a multi-span beam with multi-sections, so maybe different size beams, then maybe the smaller moment with the smaller section might produce a higher ratio than the higher moment with the higher section. So what's happening here, we're not reporting the stress ratio at the maximum moment or the maximum shear. Rather, we're reporting the maximum ratio, so the maximum applied to the capacity ratio. That's what matters to us. So that's a very important distinction here. It's obvious, but it's always good to draw those distinctions. Again, you will have information about deflection ratios. So you can see here maximum upward, maximum downward ratios, wet load combination that's controlling, and all of that. And then you will have your extreme reactions. So the reactions, for example, we have support 1 and support 2. This is a simply supported beam. So you will have the reactions actually split by the type of load. So we have dead load and live load. So we have 240 dead and 240 live. So if you add them all together, that will give you the maximum reaction. Also, you can click on this tab that says support reaction, and you can actually get maximum enveloped reaction. So you're not really sitting down here and adding numbers together. It'll give you the maximum enveloped reaction based on the controlling combination or load combination. Additionally, this is one of my favorite features, that when you click on the diagram tab and you click on moment, you can do the same thing with shear and deflection, but just for this example, if you click on the moment tab, you would have this little slide that you can go throughout the beam to determine a specific moment at a specific distance from the left-hand side. So we know this is a 12 feet beam. We know at 6 feet we will have the maximum moment. So I wanted to just know what the max moment is, since what's reported here is actually stress ratios. So, stress, bending stresses and shear stresses. So I wanted to know what the actual moment is, and you could do the same thing with the actual shear and actual deflection. So at 6 feet, we get a maximum moment of 1.44 kip feet. And what we want to do right now is just run through a quick verification example following the NDS equations to just double check that the results that we're seeing actually make sense to us. So a quick result verification here. We know that the maximum moment, because we just saw that the previous slide, to be 1.44 kip feet. If you just convert that, that'll be 17 to 80 pound-inch. So then the sectional modulus for a rectangular shape, Sx equals BD squared over 6, and that gives us 31.64 inch cubed. And the actual bending stress, the applied bending stress, is just the moment divided by the sectional modulus, and that will give us 546.13 psi. Now, what we need to do, we need to find the adjusted bending stress capacity from just the reference value. So we will use the bending stress design value from the NDS, and we'll multiply it by the modification factors. So all of the modification factors in this case, just to make things easy, we use them all 1. And the only thing that's not 1 is the repetitive member, the CR, and that is 1.15. So that means the reference value for the bending capacity is 850, and you multiply it by CR, which is 1.15. That'll give us the adjusted capacity of 977.5. And all we need to do now, we just take the actual divided by the capacity, and that will give us the ratio of 0.559, and that's exactly what's matching here, 0.559, and then these are the actual, the 546 and the 977. Very straightforward calculation, but it's a quick on the back of an envelope type of verification on the go. So moving on to the shear side of things, we're going to be doing the exact same thing. So from our calculations, we know that the maximum shear is 480. And to calculate the shear stress for a rectangular beam, again, it's 3V over 2BD. You go through the plug and chug, you will get 42.6 psi. That's the actual shear stress that's applied on the beam. And then we're trying to get the modified shear stress capacity. And that means we just take the FV, which is the reference value, and multiply it by these factors. All of them in this case are 1. So F prime V is actually 180. So 42.6 divided by 180 will give you 0.237. And this is a snippet from our calculation where we are having similar or the same numbers. So I can see from the snippet to the right, these numbers match the numbers that are produced by ENERCALC. Lastly, a quick thing, which is maximum deflection verification. Again, this is geometry dependent, and then you have the E and I, simple plug and chug, and if you follow the math, you get the 0.176, which is exactly here, and it tells you which combination is producing that, which we know, of course, dead and live. That's the combination that's producing this maximum deflection. Now, it is worth noting here that when we're doing, L over 360 or whatever we use for our design, for our deflection criteria, L is the length of the beam. So for a simply supported beam, if it's 12 feet, then L is 144 inches, which is 12 by 12. But if we have a cantilevered beam, then we use industry standard, which is 2L. So if you have a cantilevered beam that's 5 feet, for example, then for L, we actually use 10 feet, which is very, very standard, but I just want to make sure that everybody's aware of that. So in conclusion, ENERCALC various design modules are, versatile, efficient, accurate, and of course, with ENERCALC, engineers for over 40 years have been designing with confidence. So with that being said, we are ready for some live Q&A.
All right, cool. Thanks, Mac. So there's a number of good questions that might be good for hands-on work if you have a session of ENERCALC handy in the Woodbeam module in particular. There's several things we might be able to do with that. But right off the top, a question about will office hours be available for recording? Or excuse me, will the recording be available to watch later? So if you wanted to hit that real quick, just so everybody knows.
So we've been a little bit back and forth. I've been a little bit back and forth because this is meant to be a dynamic session consumed live, but we've got a lot of people asking about this and having conflicts or not being able to make it, but they still want to watch it. So what we're planning on doing, it might not be exactly happening the next day, but we're planning on doing is releasing the rough unedited recordings, and we'll put those on our website. And so please always monitor this page, which is ENERCALC office hours. So you can just find that from our enercalc.com. You go for our users, and if you click office hours, you'll come right here. You'll find all of this information about the next office hour session, how to join, and then we're going to add a place here. This is an introduction here, but we're going to add another place here where it at least gives you a link where you can watch the unedited sessions. I don't know can you see my screen? I think
yes.
now everybody can. But yeah, if you just go right here to enercalc.com/office hours, and this is the page. Keep on monitoring this page, and we will be releasing the unedited office hours in the future for sure. Unedited versions of it.
All right, awesome. And next question. How would you recommend using your software to analyze plywood beams per APA supplement number 5? So there's a short answer and a long answer to this one, and I'll start with the short answer, and then Mac can Mac, if you were going to jump into hands-on in the Woodbeam module, we can do a longer answer. The short answer is no, we don't explicitly provide support for all plywood beams per the APA supplement number 5. But what we did not do during the session in Mac's slides was dive into a little bit of the engineered section capabilities that the Woodbeam module does do, including glulam and several flavors of LVL. So Mac, do you want to take a quick spin through that?
Yes. Okay. Can you guys see my, I think my screen here is ready. Okay. So coming back here, you will have quite a variety of things to choose from. So from glulam, you have variety of engineered wood products right here, and you have a variety of things that you can work with, but also you have a user defined, and this is something that again, as you're saying, we don't directly support it, but this might be something that that you'd be interested in, is that you can actually have a user defined section. So you can just create a new section right here, and you can pretty much insert all of the values that you need to insert and start using that as as you know, your new wood material. So you'll have a little bit of additional control there to help you navigate through this.
Cool.
Yeah.
All right. So while you're here in the interface, there's another question that kind of ties in directly. A question from Pavel on the beam span data tab. I'll go ahead and pop that one here. Can you not make the type of the wood beam automatically selected with the type of the wood selected on the general tab? So what he's talking about basically is a direct correlation between the material specified on the general tab versus the beam span data where you specify section geometry. So traditionally, those have been specified individually, like Max showed in the presentation.
And this is more in line with what the NDS does, because the NDS kind of separate them as two separate things. Is it? I'm not. Is it a problem that they're not in one place? That I think I'm trying to see like what the workflow.
Well, yeah, ultimately what he's getting at is probably the fact that if you're not paying close attention, you have technically have the capability to specify a material and a section geometry that don't
That doesn't.
agree.
I gotcha.
But yeah, they've always been separated traditionally.
Right.
It's possible that in the future, if there were feature requests, it's possible that those could be connected. If there's workflow things like that that you guys are wondering about or things you'd love to see changed, be sure to send those to the support team, support@enercalc.com, because that's how the engineering team and the director of engineering set those priorities for future improvements and changes to the software as well.
And I want to add another thing to this. I like that they're not hard tied. I understand that, of course, there's the potential of going sideways, but I like that they're not hard tied because I can now have my own little material that's not hard tied to a 2x4, for example, or 2x6 type of especially if I'm working with something weird or working something engineered. Like I like that they're two separate where the material is not hard tied to a specific type set of sections. So this way, if I want to have additional versatility, I can do whatever I want to do. But at the same time, of course, we have to be careful because if you're on autopilot, you might miss it.
All right, and also directly related to the wood beam interface you're looking at right now, question from Matt. The use of pressure treatment reduces the structural properties of the wood member. Are there plans to include these reduction factors into the wood modules? So if you look at the beam span data tab, what you're typically looking at when you introduce the effects of pressure treatment normally is the incising factor or the CI from the incising that happens so that the section can absorb the pressure treatment. And so you do have the ability to toggle the incising factor on or off. If that checkbox that Mac is showing right now is cleared, then if you go to the Max Combinations tab on the right-hand side of your screen, on the output side, on that Max Combinations tab, you'll be able to scroll all the way across and see the various C factors that are being used. And you'll be able to see that your CI factor is not in play. And you should be able to see that that CI factor takes effect using the appropriate NDS value if you are using a pressure treated section. Now, those are set using the specific dictated CI factors for section type and section geometry. You don't have the ability to go off-road and separate or manually input what CI factor you'd like to use. So another question here, does the beam program do biaxial stresses? And Mac, you can go ahead and take that one.
Yeah. So the beam is only handling loads in one axis, which is the standard, but you can do that in the column. So if you click on the wood column module, you can actually use that as a kind of as a beam column type of thing. So you can for example, you can just have here your settings, all of this stuff. I'm just gonna use anything for now just to kind of set something up. So you can come right here to 2x6 loads. So you can apply loads, axial loads, but also if you don't have any axial loads, you can apply lateral loads. Now these loads can be applied in both directions. So you can apply something in the YY direction or the XX direction. So you can control that. Let me see here. So if we have, for example, 0.5. So you can apply it in either direction, in the XX or the XY direction. And we talked about this last month. You actually have the ability to control slenderness and beam stability factors separately. So for slenderness, you have, whether it's fully brace about the X, or fully brace about the Y, or whatever you have here for Euler buckling. But then once you get to this tab right here, that is the beam stability factor. You can just say, okay, well, I have my whole thing is completely unbraced, or maybe braced in the middle, or whatever, and then you can do the same thing for Fluxure about XX and Fluxure about YY. So you have those controls. You can do a beam that is loaded in both directions, X and Y, and even if you want to add an axial load to it, pretty much all three axes, and you have a fantastic amount of control, especially when it comes to calculating the moment capacity, using the beam stability factor, and of course calculating the actual Euler buckling using the slenderness values. So you can use this module to do a biaxially loaded beam. And this, I want to elaborate just a little bit, and I think I talked about it last month, but I want to elaborate a little bit. This is not just specific to wood, but even if you click on the steel column module, you will have the same control. So you can just go through all of this. You have your slenderness. You can choose your bracing for Euler buckling, which is your axial load in this case, and then you have your beam stability factor for something like this around the X. So you can also control that here as well. So this is not, you can do it for steel beams, of course. You can do it for wood beams.
Perfect. So kind of a follow-up question related to that further down. Are there plans to include biaxial bending into the beam module? And that kind of ties in directly to what I was mentioning earlier. If there are features of behaviors like that are important to your team, we definitely encourage you guys to reach out to the engineering team, support@enercalc.com to that's how things climb the leaderboard to decide what gets priority. And so if those are things that are important to you, definitely reach out and let us know about that. All right, so we had another question. This is from Shaylin, related to, this one's kind of a long one, but I'll kind of read through it here. So if you have a high wind load where you have overall uplift for a load combination, talking about load reversal on wood beams, and this is similar to the discussions we've had in the past about load reversal on a steel beam, whether that be a wind uplift condition, whether it be a multi-span or a backspan and cantilever condition where you get load reversal, talking about the flange bracing conditions, compression, side of the member, and then that load reversal, you get a reversal of the flange bracing. So, Mac, you can go ahead and go through that interface.
I want to elaborate on this a little bit to make sure that we're on the same page. So there are two important features that I want to make sure that everybody understands. So as far as the loads that we're applying, does ENERCALC understand the directionality of the load? 100% yes. If I do this as negative, it will change the value. So let me actually do this here. So if I apply it as downward, you can see here that's 279. The stress ratio, the applied moment is 35 kip feet. If I just change the direction of this, it understands that something changed, and now your applied moment, its maximum is 28. So does ENERCALC understand the positive and negative of the direction of the load? Yes. Now, what you need to know and what you need to be careful of is how this factor right here, the compression bracing, this doesn't tell you if it's the top that's braced or the bottom that's braced. It assumes that the compression side of the beam is braced. So if you are in a complete uplift situation where the bottom flange is the compression flange, then it expects you to tell it what that controlling bracing is. It expects you to know that, okay, if the bottom is controlling, then this is not fully braced. This is maybe braced at every 5 feet. We have a kicker or something. Then I'll have to go here and adjust this separately. So it can say that, okay, this is happening
at 5 feet. So it's important that as you're working on your design, and if you know that your top flange, or is the compression flange, then you apply the bracing that's appropriate to that. If you know that the compression flange is going to be the bottom flange, and aka having some sort of an uplift case, for example, then you need to make sure that you put the actual bracing spacing that you have for that bottom flange, which is the compression flange in this case. So it's important for you to know what the software is doing and use it in a proper fashion to get the right results. The last thing that I want to say, currently there is no way for you to set top bracing separately from bottom flange bracing. So right now there's just only one set for this, and it's tied to the compression edge of the beam. If the compression edge is the top, then that's what it's going to be. If the compression edge is the bottom, it's just going to assume that that's what's going to be. But currently it doesn't allow you to give it a different bracing spacing or bracing conditions for the top portion versus the bottom portion, as of yet, or as of now.
Perfect. So one or two other questions directly related to wood beam, and then I want to jump to one that's a little bit broader, but it's a kind of a great hands-on, like the building code information that you went through earlier. So last question about wood beam for right now from Caleb. Is there a way to calculate sistered beams of different sizes and grades? And Mac, feel free to elaborate, but I believe the answer is no to that right now. You do have the ability, whether you're doing LVL, whether you're doing dimension lumber, you can do 2-gang, 3-gang, whatever, of the same size and the same grade. I don't believe we have exposed the capability to do sistering configurations with different sizes or different grades.
That's correct. Yeah. The only thing we have here is the sistered members have to be of the same size. So like 2x6s or 2 plies of 2x8 or whatever. Another tool that's useful, and I know I'm jumping, it's a tool that I like a little bit, but
you go in section property builder.
Yes.
Yes.
So the section, where to go here? In analysis, the general section property calculator. It's an extremely versatile tool. A lot of people use it for steel, but you can use it for anything. The bottom line is that, let me do a sketch here, for example. So you can build whatever you need to build. So for example, if I want to build a rectangular shape, I can just do this, click rectangular. I'm going to do a width of 1.5 and a height of 9, or maybe like 5.5 inches. So then I can do this. I can go and I build another one next to it, for example, that is 1.5, and maybe that one is 9.25. So it's a 2x10, and I want to move it in the X direction by 1.5 inches. So then, we can work with it. You can move the centroid minus 3 inches, I guess. Yeah, with a little bit of playing, just do a little bit of math, you can do something like this fairly quickly. You have all kinds of shapes. You have a variety of things. You can do hollowed sections. You can do weird shapes. You can do everything you want. And my personal favorite is that a lot of times when you do a composite steel section, or a built-up steel section, you can actually browse steel sections here, and you can bring in. So, for example, if I want to bring a W6x8, I can just bring that right here. I can move it, maybe 8 inches or something. If you're trying to build something, if you're trying to build something, you can do whatever you want to do. I'm just going to get rid of this real quick, delete this section.
And this is it's pretty common for ENERCALC customers to use this as a companion tool with the general beam analysis module, because the general section property calculator is giving you all of the critical properties you need for bending analysis, as well as things like your R, X, and RY that you would need for elastic buckling, axial analysis, and so on, that you can feed directly into a hand calculation. Or if you're doing bending, go over to the general beam analysis module, feed in your I, and get both deflections and reactions.
You stole the words right out of my mouth. That's exactly what I was leading to, is that here in this calculations page, you can see all of the, the properties, dimensions. You'll get all the information you need for this composite section or built-up section, and then finally you can use that information to do. If you want to do hand calcs, if you want to do whatever you want to do, use the general beam calculator. You can do a variety of things that would be quite useful.
Awesome. So we're close to the end of the hour here, but there was a great question that I wanted to hit from Steve. Any reason that the code selection and load combination selection aren't just linked to each other? So this is another one of those where there's a short answer and a long answer. The short answer is flexibility.
Yes.
The long answer is, and Mac can kind of drill into this, but the long answer is because the load combination options that you see when you're setting up your calculation are not directly linked or inherited from the building code IBC version you've specified. Those are just a preset out of box set of combinations. You can actually go and define your own preferred set of combinations, whether those have special modifications, what have you. And if you guys aren't familiar with that, if you look at the top of the ribbon bar here in Mac's interface, where he went to the settings dialog or that settings drop down menu to show you guys, the drop menu right next to file.
Yeah.
If you go right next to that, you see databases rather than the settings menu. And under that databases drop down, you see load combinations. So the load combinations that you see the option to choose from in each of your calculations can be modified, or you can even create your own sets. And you can create as many load combination sets as you want. You can modify those factors. You can name those combinations whatever you want them to be named. And then whatever you set in this dialog is what you'll be able to choose from the dropdown in each one of those individual calculations in each one of your project files. So the reason that you aren't bound to just what's contained in your particular version of IBC is because you have this menu, which opens up all that flexibility so that you can create your own combinations over time. See, now that Mac has created this extra load combination set, he would be able to go all the way back to an individual calculation and use this special set of load combinations he's set up. And so that's the reason that they aren't just simplistically linked to each other. And if he wanted to, he could go all the way back and show that. Exactly.
Yeah. Once you create it there, you can always have it here. And then if that's what you want to use for all of your projects in the future, you can always set it up here. Or if you want to use it for this one project, you can just use it and click on save and continue. But at least we try to have both the, like, I want to get back to why they're not linked. I think it's one of those things. If they were hard tied, personally, I would have hated it, because I would have wanted to have a little bit more control. So it's good that we have the flexibility to choose them independently, but we can always set some defaults so this doesn't become a nuisance for our projects. If we always use, or at least if we always use a IBC 2018 or whatever, we can always set it as a default and not have to worry about it and adjust it per project.
Yeah, exactly. Question from Eric. Can you add notches or holes into members? Presumably he's thinking of wood members, since that was the topic. And Mac, that's probably going to go straight back to what you just mentioned a moment ago.
Yes. Yeah. So the native here, the native module doesn't, but if you have notches and holes and weird things, then you can always go back to the general section property calculator and say, okay, I have something weird, and you can just create a general section and you create this, and then you start adding holes or doing whatever you need to do in order to build the shape that that matches what you need.
Perfect. All right. Well, we're basically down to the end of the hour here, so we're going to go ahead and wrap it up. But we do have one final question I want to toss you, Mac, and this is kind of a great question about what's coming in the future. A question from Connor. We got a new letter saying that load linking between analyses was a recently implemented feature. Is that accurate? So what's going on with load linking?
Okay, this is very exciting. So we hopefully soon, it's in the final stages of testing. I've been getting a lot of questions about this. So It's in the final stages of testing, and what we have is native load linking within ENERCALC. And once it's released, we will definitely talk about it. But in a simple manner, when you have a beam that maybe sits on a girder, and then a girder that sits on a transfer girder, and then a transfer girder that sits on a column, normally you will have to grab the reactions manually from beam number 1 to the girder and then and so forth. So you'd have to kind of carry them down manually. And then if something changes in the first beam, then now all of your reactions have changed. And then, of course, you'll have to redo all of that work manually. And a lot of times it doesn't get, a lot of time it gets missed. Definitely most of the time, I'm talking from my experience working as an engineer, I normally take the envelope reaction. I never try to carry the specific type, if it's dead load or live load. This is too much work. So I'll just carry the envelope reaction, and that, of course, creates extra, and apply it as a dead load. So that's a little too conservative, and that carries down a little bit. So what happens now is that you can create beam 1, for example, and then when you go and you create beam 2, you can say, I want you to apply the reaction, the left reaction, for example, from beam 1 at the midspan of beam 2. So now you're linking your calculations together. So if the first beam that's transferring a reaction to beam number 2, and then beam number 2 transferring reaction to beam number 3, if beam number 1 changes, all of these reactions, all you have to do is just click a recalc, and all of these new changes, the new reactions, will carry, and then it'll tell you if anything changed, or if there's throw a red flag if a size is not working or something like that. This is a huge time saver for us, especially working on smaller buildings and designing, a building one component at a time. Especially if you're doing a foundation and now something all the way above changed, and now you're trying to carry your loads all the way down. So it's going to be a huge time saver, and I cannot wait for it to be released. 100%.
Yeah, we're pretty
Now,
excited about that.
also, yeah, so that's for load linking, and then also just want to make sure that everybody knows that we are working on IBC 2024. So we're in the process of that. We've got a lot of course, a lot of questions about it. We're working as hard as we can, as fast as we can to support it. Right now, we support up to IBC 2021 and all of the reference standards there that correspond to it. But we're working diligently to get IBC 2024 as well to be up and running.
Perfect. Yeah, and I just wanted to add to that. Load linking did actually go to our very first beta tester this week. So there's a version of load linking out in the wild to a select group of beta testers, and we're hoping for a public release on that very soon. So stay tuned for more announcements on that. I'm sure we'll have an office hours on that. Here's an easy one for you, Mac. Question from Hamal: is ENERCALC already incorporated with Revit modeling?
Yes, there is a product called ENERCALC for Revit, and I feel bad talking about it in Seth's presence, since he's the he's the guy. But yes, there's a product called ENERCALC for Revit, and as you can see here, I don't know, maybe that's what triggered the question that says Revit mode off. This right here, it's off now, but pretty much you can model your building in 3D, and then all you need to do, you can just click on a beam. You don't have to export a model. There's no analytical model to export or massage or anything. All you have to do is just you click on the beam from within Revit, and you click on it and you say design steel beam. It'll automatically detect geometry. It'll automatically detect if you have area loads or any loads applied in Revit. It'll automatically detect that. It'll detect the supports automatically. It'll do live load reduction for you automatically, and it will open a calculation for you in ENERCALC automatically. And let's say you change sizes from a W8 to a W12, and you click OK in ENERCALC. It goes and it updates it in real time within Revit. So you're always having a model that matches your calculation with zero chance for transcription errors, which is something that we always have to deal with whenever we maintain two separate models, like an analytical model outside and a drafting model within Revit. So that's also a very exciting thing. Seth, if you have anything more to add to this, I know this is your thing.
No, that was a great overview. ENERCALC for Revit currently includes complete integration for beams and girders in steel, steel composite, and wood. Steel column we debuted at the Steel Conference in April, and that's about to have its public release right now. And then general foundation in active development as well. So we're very excited to see steel column integration in Revit and general foundation release, hopefully this summer. And then we're slated to demonstrate those in conjunction with an ENERCALC customer at Autodesk University this fall. So with that, I see a couple other questions we didn't get to. A question from Satya about wood shear wall. Wood shear wall is a very popular tool and much beloved among our customers. It might make a great topic for our future office hours. If not, Mac will probably be reaching out to the folks whose questions we didn't get to today. But with that, Mac, do you want to have any final comments? And we'll go ahead and wrap it up and thank everybody for being here today.
Yeah, thank you. We're good for today, and definitely, if you have any questions, please send them to our email, officehours@enercalc.com. I try to answer a lot of these questions. We provide answers to as many of these questions as possible, and we incorporate them in these sessions. So please keep sending those questions to me.
All right, and Mac, do we have a date set for our July office hours? Or just announcement forthcoming?
I do have one. It's the 10th, July 10th, because
fantastic.
we were thinking of doing it before 4th of July, but we figured people want to take a break from work. So July 10th, that would be the day.
Gotcha. Okay. Well, once again, we thank everybody very much for being here. Stay tuned for your updates that we'll be sending out for July office hours. Send those questions in so we have Q&A and topics for our future sessions. And thank you all very much. We'll look forward to seeing you next month.
Thank you.